Hi everyone, this is Melody Rondeau and I'm going to be taking us through the rest of our lesson on displaying quantitative data with graphs. So our learning intentions for today, I'm learning how to display quantitative data and describe the pattern of a distribution. And also we have a second one today, I'm learning how to compare distributions of quantitative data. Our success criteria, I can make and interpret histograms. I can describe the shape, center, and spread of a distribution and identify outliers. And finally, I can compare distributions of quantitative data. Let's get to it. If you do need more time, feel free, of course, to pause the video at any time and catch up. Here we go. So histograms. Histograms are when we have data values that are grouped into bins, kind of like bars. The bins are basically like the bars of a bar graph. Bins must have equal intervals, so they're the same width across. 5 bins is a general minimum, so when you're building a histogram, typically we want at least 5 bins or bars to set up our data. Frequency histograms are going to use counts because that word that we've seen before, frequency, this one right here goes with our word counts. It means like literally how many or the number. And then we have relative frequency, which we talked a little bit about this. This relative frequency is the same as percents. So frequency means counts, relative frequency is percents. Okay. Example 1. The table presents the average points scored per game. So that's PPG or points per game for the 30 NBA teams in the 2012-2013 regular season. Create a frequency histogram and a relative frequency histogram to display the data. All right, so part of the process, like we did with dot plots, is kind of getting a sense of how many numbers or how far our numbers are spread out. We call that the spread. So at the top of our data, it has a place for us to put in the smallest value and the largest value. So if you look through the table, you should find the smallest value is 93.2. It looks like that's the Chicago Bulls. And then the largest value is 106.1. Where did I see that? 106.1 there. Well, 106. Maybe I made it up. Oh, there it is, Denver Nuggets. Okay, so those are my values, 93.2 up to 106.1. So as I'm setting up my bins or my intervals, that's basically like the bars, I need to make sure that I set them up so that I include the numbers 93 all the way up to 106. When we do histograms, we cannot have gaps like when we did a bar graph. So my histogram, since my smallest value is 93.2, I'm going to actually start my bin interval at 93. And I'm going to go up to, but not including, so I'm going to say less than 95. So essentially, I can't overlap. I can't use the number 95 twice. I have to just say up to 95. And I can make the choice whether I include 95 here or I include it in the next one. I'm making the choice to go up to 95, so then my next interval would be 95 up to, and here's where we have to be extra careful. Remember to think about what numbers I'm including. So 93 up to 95, so 93 to 94, that's 1. 94 to 95, that's 2. So just on the shy side of 2 because I'm doing less than that. So this would be 95, 96, 97, so less than 97. And then the next one is 97 up to less than 99. Then I have 99 up to less than 101. And then I have 101 up to less than 103. And then 103 to less than 105. And 105 to less than 107. Now, I don't actually have data values that go all the way up to 107, but I do have to keep a consistent bin interval. So I made mine roughly 2 units long or wide, so I have to keep that pattern. Okay, once we have that, then we're going to go through and count all the data, and I'm going to do this. I'm cheating because I already have it done ahead of time, but you guys would go through and count how many teams had values from 93 up to but not including 95. All right, so I get 9 for my count, and then I go through again and continue to do that for each category. So 95 up to but not including 97, I get 5 of those, 5 in the next category, 2 in the next category, 5, 1, and 3. And again, you can double check my work or look them up there in the table. Cool. Once we have those, that gives us our count, which will help us build our frequency histogram. So remember, the frequency goes with the counts. So up here, I'm just going to make a note. This one is frequency. This one is going to be relative frequency. Okay, so for my relative frequency, I have to go through and create percents, which means I'm taking the number that fit into my category out of the total. So that means 9 out of the 30 teams. And I would turn that into a percent. I get approximately 30%. 5 over 30 here. That one gives me 17%. Another 5 out of 30 is going to be another 17%. 2 out of 30, I get 6%. 5 out of 30 again, another 17%. 1 out of 30, that's 3%. And 3 out of 30 is 10%. Now, I should be able to go through and add those all up, and it should equal 100. So now we're going to go ahead and build our histogram. So here goes. I'm going to go to a new screen just so I have some space. All right, so I'm going to start by setting up my axes. So there's my first one, and I'm going to jump my graph here, so I'm going to kind of do one of those no-nos that we talked about for the vertical axis. For the x-axis on a histogram, this is actually okay. I know that seems crazy, but we're going to start, our graph starts at 93 and then goes up by 2, so this would be 95, 97, 99, 101. I'm going to try and squeeze these in, 103, 105, and 107, something like that. And in theory, they should be equally spaced. You can see mine are not so good. Let me see if I can fix this without terribly changing my graph. All right, so once I have that, I'm going to also make sure that I label this. So I'm going to give it a name. It's a little better. This was points per game. And then I also need my, that was PPG. I also need my y-axis. So on my counts or my frequency histogram that I'm building here, the counts, the highest I had was 9. So I'm going to try to split this up 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's my 9. And this is 1, and of course 0. 1, 2, 3, 4. I'll give myself a 1 in between. There we go. And this one I will actually give a title. I'm going to call this NBA Teams PPG, points per game. And now I'm ready to put in my histogram. So for my histogram, I'm going to be putting in the numbers that we had. So from 93 up to 95. So I started at 93. And I went up to 95. That had 9 teams. So just very similar to doing a bar graph, I'm going to put in a bar. But you'll notice there's no gap because the first bar goes all the way up to 95, but not including. And then 95 starts the next group, which is at 5. And actually I have 2 groups at 5, so I'm going to kind of build 2 at once. Well, I tried. Let's try that one more time. There we go, it's a little better. All right, and then after my 5s, I had a 2. So I'm going to go up to 2 and draw 1, and then back up to 5, it looks like, then 1, then 3. So 2, 5. Well, that one was terrible. Sorry, I got to redo it. It's just horrible. One more try. Okay, well, we're just going to live with it. 5 and 1 and 3. So something like that. And that would be our frequency version. Oh, I forgot to label this side. It's frequency because these were the counts. All right, so we're going to do the same thing over here. We're going to repeat our stuff, except this time we're going to do relative frequency. So I'm going to have, actually my x-axis is basically going to stay the same. I'm going to start at 93, and then I have 95. Try that again. 95, 97, 99, 101, 103, 105, and 107. So basically building the same scale here. I'm going to see if I can fix these two guys a little bit. All right, and I'm going to have the same label across the bottom. This is points per game. And that is PPG. And then I'm going to do something here because I want us to see how these compare. So I'm going to, my highest percentage was 30. So I'm going to come up here to the top. And I'm going to go ahead and count by 5s, I think. So I'm going to do, halfway would be 15. Excuse me. And then I would have 5, 10, there's my 0, 15, 20, 25. And this time these are percents. This is my relative frequency. And again, the title at the top. Sorry about that. And again, the title at the top. And again, the title at the top. And again, the title at the top. Sorry, my little pen was being a little funny a second ago. There we go. NBA teams, PPG. Okay, so my first group here was the 30%. So I'm going to go all the way up to 30. And then my next 2 bars are at 17%. So that's going to be roughly about here. And then my next one was 6%, so there's 5, so just above the 5, there's 6%. Then I have another 17, so back up to the 17, something like that. That one's really skinny. Let me see if I can fix that. A little bit here. There we go. And then down to, let's see, 3% and 10%. So 3% would be somewhere here-ish. And then 10% about here. Hopefully, what we're supposed to notice is regardless of whether I do counts or percents, that the information is the same in terms of what I end up with as a histogram, as long as my scaling kind of matches up and I start them out at the same height, then I will have the same histogram. And to show that one more time, so that's the end of that question in terms of building our histograms. This is what it looks like from a computer generated version. So you can see that same idea. All right, so histograms versus bar graphs, what's the difference? We talked about histograms are going to display our quantitative data, while bar graphs are used for categorical data. Bar graphs have spaces between the bars. Histograms, there are no spaces unless there's no information. If it's 0 counts for that bar, then it would be, there might be a gap. We would call that a gap, not really a space. All right, so on to example 2. The back-to-back stem plot below shows resting pulse rates of 19 middle school students from a previous example and their pulse rates after 5 minutes of running. Compare the distributions. So this one is an interesting thing. We have our regular stem plot. This is called a back-to-back stem plot because we have the information on the left is one of our sets of data and the information on the right is the other. And so we're seeing them back to back. And it kind of gives us a view of what's happening. Notice it does include the key. And so let's take a look at what we can do here. It does say compare the distributions. Anytime you see this, compare distributions, that means we are talking shape, center, spread. So I'm going to start with shape. And we would need to comment on the shape. So if I look at the resting stem and leaf plot, it looks like it is actually skewed right, which I know is maybe difficult to see. It's skewed, like the trail goes towards the bigger stems, which normally would be this way, and it would be trailing to the bigger number, so that would be my skewed right. I know it's kind of hard to see like that, but thinking about going to the bigger numbers means going right. And the other graph also is skewed right, again going towards the bigger numbers. So they both kind of have a skewed right shape. So I'm going to say that both distributions are skewed right. So there you go. That's pretty straightforward. They both kind of have the same thing. The only thing I might also comment on shape, which is kind of more center, is the fact that they're centered in different places. So actually I'm going to comment on that in center. So in my shape center spread, here's center. I'm going to say, looking at the one on the left first, the resting pulse rate. So the resting pulse distribution, actually. Can't spell distribution all of a sudden. The resting pulse distribution is centered around 7. That's me making a guess. I'm sorry. I'm saying 7. That's my stem. So keeping in mind what that means centered in the 70s. So actually I should make that fit the context rather than saying 7, the stem. I can see it's kind of centered in this general area. So I'm going to say around the 70s. While the after exercise pulse distribution is going to be centered, let's see, looks like it's centered kind of more here in the 90s. So is centered in the 90s. All right, so we have shape, center, and then spread. How do the spreads compare? So their spreads are fairly similar. We do have the after exercise is a little bit higher, but the length of the spread, this one goes, where'd it go? Sorry, I lost my pen for a second. There it is. Okay, so this one, the resting starts at 660 and goes to 120, so that's kind of a width of 60, so to speak. And this one starts at 80 and goes to 140, which is also a width of 60. So they are about the same spread, but they're just kind of shifted in where they're located. So I'm actually going to say their spread is about the same. Just shifted from one another. I might specifically comment the resting range is, let's see, 68 to 120. While the after exercise range is 86 to 146. And I should put in there beats per minute. That was our thing, even though I don't think it says it on this one, but it was beats per minute. Always good to include the units and the context. Okay, so there's my shape, center, spread. The last thing is when we are comparing, not only do we talk about shape, center, spread, but we want to make sure to talk about any outliers. So I'm going to mention, if I look at my data here, it looks like both distributions have possible outliers. Notice here I am saying possible again because we don't know for sure, but it appears that let's see, one of the outliers appears to be possibly the 120 for the resting data or the resting distribution. Say distribution. And at 146 for the after exercise. Distribution. All right, we made it. It's a lot of writing, but there we go. Okay, last one, I believe. Taking a look at histograms. So that one we got to look at stem and leaf a little bit more. So now back to histograms. The histograms below show the distributions of strength when wet for Bounty paper towels and a generic brand of paper towels. Statistics students soaked a sample of each type of paper towel in water, then held opposite edges of the towel and counted how many quarters the towel could hold before ripping. Compare the distributions. So here goes for this lovely one more time comparing. So we are going to be doing shape, center, and spread. Here we go with shape. If we look at the two shapes, it looks like my Bounty is fairly symmetrical, maybe a little bit askew to the left. And then my generic looks fairly symmetrical, possibly a little bit, fairly symmetrical. I think it's fairly symmetrical. Okay, so we're going to say the Bounty distribution is slightly, because it's not very much, but I do see a little bit there, slightly skewed left, while the generic distribution is roughly symmetric. All right, so there's our shape. Then we'll go on to center. Comparing the center of these, they are very different in where they are centered. So starting with the bounty distribution is centered. And let's see where it's centered. It looks like it's centered at about close to that 124, but since it's skewed a little left, I'm going to say it's centered about 120. And sorry, I should say at about. My grammar is a little off there. Is centered at about 120 quarters, while the generic distribution is centered at, let's see, that one looks like fairly centered at 88 quarters. All right, we got shape, we got center, let's do spread. Our spread, again, fairly similar in how wide it is, but located in different places. So I'm going to say both distributions have a similar spread, but bounty but bounty is shifted to the right. I'm going to say shifted right. And I'm going to explain that here. Looks like 111 or so quarters. I don't know. Maybe I won't worry about it. We'll just leave it. Sorry, it's kind of hard to estimate those numbers. And we don't have the actual data. So I'm going to say shifted right or higher compared to the generic. All right, so we have shape, we have center, we have spread. And the last thing we need to comment on is outliers. With this histogram, if I look at these, I don't really see any. So I'm going to say for our outliers, appears to, oopsie, having trouble writing, appears to be none. I might just comment both. It doesn't look like either of them have an outlier. Maybe I'll say it that way. None for either distribution. All right, people, you survived shape, center, spread, comparing our two distributions. So there you go. Double check that does finish the lesson here. So go ahead and check the success criteria. I can make and interpret histograms. That was example 1. I can describe the shape, center, and spread of a distribution and identify outliers. We did that in examples 2 and 3. And I can compare distributions of quantitative data. That was examples 2 and 3. So if you've got them, check them off. Otherwise, circle them if you're still not sure. And check in on Google Classroom for other assignments. Thank you guys so much. Have a great day.